Get the recording going. All right. Well, welcome to our last week. You made it this far. A couple days of review, whatever we need to get through. And Wednesday is the scheduled test. Thursday is set aside as a day that everything is still available for you to look at your grades. I should have your grades posted by Thursday. And or at least in Mom, right? It'll all be in Mom. You can look at your grades in Mom and ask questions. Probably wouldn't expect to hold a class on Thursday, but still be around for you to ask questions and I can respond. Let's see. Oh, just wanted to mention, I mean, you should be able to see, I think I've changed the settings. You can see your test grades on the last test. There comes Sasha. Yes, she's sideways. I don't know what happened there. Yes, you should be able to see your grades from last test. If for some reason they're not visible, let me know, and maybe I need to fix the setting. I just did want to mention that at least for the last couple of tests, if you did get something wrong, I tried to leave some feedback. If you look at your test grade in the grade book, for instance, there's a score and there's probably an asterisk next to your score, which means I left some comments of, about errors that you made. If it's not obvious to you how you might have made a mistake. So I tried to point that out. So you can go back and look at your work, look at the preferred answer, the correct answer, and figure out maybe what you did wrong. So just encouraging you to look at what little bits of feedback I tried to give you there on mistakes you might have made. Okay, so our test on Wednesday is really the same format. I think there's 14 or 15 questions, kind of like the last test. I'm going to give you a little extra, 15 minutes just to be sure, hopefully that's enough time for you there to get through that. It is a cumulative test. That is a little bit of stuff from all throughout the term. And the course requirement is that you have to pass the final. So even though you may have an outstanding percentage right now, you've still got to get 70% on this one specific hurdle, pass the final. Okay, but I'll be looking at it and adjusting it if appropriate based on your work, just like all the other tests. Okay, so that's kind of the way the final works, just like all the other tests, really. Just want to make that clear, though. All right. Any questions about the logistics there here? Well, review them, right? So chapter 1 was really intended to sort of refresh your fundamentals, you might say, kinds of materials that we often cover in Math 20 for a whole course, really. But we did things like simplifying expressions, right? No equal signs really yet, right? We just had those order of operations rules that we followed, simplifying expressions. Which thing were you supposed to do first? What order, right? And then we, basically being able to add, subtract, multiply, and divide with integers, right? The positive numbers, the negative numbers. And then we added the fractions. We want you to be able to do all that same kind of stuff, add, subtract, multiply, or divide with fractions. So I'm kind of talking through the first chapter because honestly, the final is not going to specifically test you much on first chapter stuff. I'm going to kind of expect that you can simplify an expression, understand that you can kind of move pieces around following commutative property like add, addition, and multiplication. Understand the distributive property. Multiply that outside number times each term inside, and you can use those rules. I think we talked about the different sets of numbers in that first chapter, where we basically, well, we introduced the integers, the negative side of the number line, right? And the fractions, the rational numbers, ones that you could write as a fraction. And I think even there we introduced the idea of irrational numbers, like the square root of 7. Well, you can't write that any simpler without coming up with an approximation, right? A decimal version, 2 point something or other. So we also addressed like rules for rounding, right? Rounding say a whole number to a certain place, like the 10th place or the 100th place, but more often it's those decimal values, 3.4769, whatever, round to 2 decimal places, round correctly. So we practiced doing some of that in that first chapter. We also introduced some geometry, really as a way to plug numbers into formulas and do some simplifying of those expressions to come up with a single value, simplify those formulas. So that's, I'm kind of waving my hands and say that was chapter 1, right? And then we went on to chapter 2 and 3, which were combined. Now I guess I'll just stop and say, if any of that strikes you as something we should spend a little time with right now, chapter 1, simplifying some expressions or some combining like terms, that kind of stuff. Are you totally comfortable with that, or should we do something from those concepts? So please, jump in and say, can we please do this if you're feeling that, okay? Chapter 2, solving equations. So we started mixing in. Well, we took those expressions and we said this expression equals that expression. And so we have a full range of complications, you might say. The simplest ones where you just had to add something to both sides or subtract something from both sides, or multiply or divide both sides. And then we started mixing those things together, right? 2x plus 3 equals 8 or something like that. And then had to do a combination of add, subtract, and multiply or divide. We ended up with some equations where we have variables on both sides as well as the constants, just the numbers, right? We had to choose to move all the variables to one side and move all the constants to the other side. So eventually we could winnow it down to x equals something. Introduced equations, then it also required some simplification of expressions on each side, right? We had to do some distributing and then probably combining some like terms on maybe one or both sides of an equation. And then that usually involved, okay, now let's get all the x's on one side and all the numbers on the other side to keep going like that, right? So more and more complicated versions of, solving those equations. We also did some with some fractions. We had a technique for, multiply by the common denominator. Let's get rid of all the fractions. And then it looked similar to the, let's say, simpler versions that didn't have fractions in them. All right. Again, still just kind of talking about the different kinds of things that we did there in that chapter. I have my recommendation for you to prepare beyond what we might do here is to look at those review sections, those chapter reviews that were accompanying the tests. Right before each test, there was also always a chapter review. The one in MOM, and really our test questions were always very similar to the kinds of questions that were in the MOM reviews. And honestly, the final is going to be problems that are chosen similarly from the different chapters, the different chapter homework assignments, homework and or tests. So they should look very similar. But I would encourage you to look at those reviews, all right? The chapter 2 review, the chapter 4, the chapter 5 reviews as a good practice or ways to prepare for the final. And I have my copies of those here available to kind of pull up some problems if we want to do some of those. Within that solving the equations, there were some of those, special ones where this one is called an identity because 0 equals 0, that it's always true. Remember that? Always true is an identity. Or, 0 equals 5. It's always false. It's a contradiction. There's no solution, no number that would make it true. Right? After you did all that work, you got down to this thing that has no variables and it's not true. Right? And so we had those classification terms, right? An identity or a contradiction. And if there was just a one solution, it was called a conditional equation. Condition is one condition that works. We applied those solving techniques to just formulas. Maybe it looked like a familiar formula, or maybe it didn't. It was just a combination of letters, no numbers, maybe sometimes some numbers, but here's this formula and we want to solve this formula for this one letter over here. So we had to use our solving techniques to rearrange the formula. And that always, basically, that was chapter 3 was about, was applications, all right? Can we interpret a word problem and come up with the equation that represents the situation and then solve that equation to find the solution to that application?
Steve?
All right.
So I'm on my phone right now because my laptop wasn't working, but I got it to work. So I'm going to quickly leave and rejoin on my laptop.
Okay, no problem. I'm going to take a drink of coffee. Yeah.
Okay.
Yeah, no problem. I understand. Still hot. So that means I have to let her in again. There she comes. Yeah, good. Had to let you in again. I hope everybody had a good, holiday and was safe, right? And I'll just say, for most everybody, you didn't miss me too much last week. I thought we were in good shape as far as the review was concerned, and well, for the most part, that seems to have panned out that way also. So good for you. Anyway, yeah, we got through that. You got through that. Most of you got through that last test. All right, so we were talking about basically chapters 2 and 3 were solving equations, and then we got to some applications in chapter 3, where we basically created equations that we had to solve the word problem. So I'm still just kind of talking. So somebody will want to say, let's do some of these, or let's do some of those. And you feel pretty comfortable with being able to distribute and simplify on both sides, and then add, subtract, whatever to solve an equation. If there was a fraction, so we do a fraction equation. Let's multiply by a common denominator. You're okay with that idea? I'm going to get rid of the fractions, and then we do the same things, add or subtract, multiply or divide to solve that equation for the variable someplace, right? Let's see. What else we got here? Different kinds of applications. Some were just like what I might call number problems or number puzzles. The sum of 3 and 6 times a number is 17. Find the number. So you had to translate that statement into expressions that you could write an equation out of. Then some of the equations, sort of got into more of a real application context, right? I'm looking at one here off the review. Mark needs $320 to buy a bike. He has $35 saved, and he's going to save $15 a week. How many weeks does he have to continue saving before he can pay for that bicycle? Oh, that's almost like a setup question. They're getting ready for it. Y equals mx plus b, right? That's where they actually told you the why. Here's the final amount that you've got to get to, that 320. And he's got 35, that'd be like the B, right? The starting amount, plus $15 times X, 15 times every week. How many weeks? So that really was a Y equals MX plus B shape problem, shape equation where they already told you the Y, and so now you got to find the X, something like that. Right? We did a number of, we did a couple, well, again, here's where I would sort of claim we did geometry plot problems, but really as an excuse to write an equation. And back in chapter 3, we actually did perimeter problems without talking about them as substitution problems, right? In chapter 5, we went further and said, well, actually that little L equals, length equals twice the width plus 5. That's really a separate equation that we're going to use to substitute. But we just kind of did it in our head in chapter 3, and we found the perimeter of a rectangle by solving our basic perimeter formula. Kind of we're going to expect you to understand the perimeter formula, right? The perimeter is twice the width plus twice the length. You need to come ready to use that. We did similar problems with triangles, right? Where we had to know all the angles added up to 180 degrees. And then there was relationships between the different angles. One angle is twice the other. The third angle is 5 more than the first or something. I'm just making up stuff off the top of my head, but we knew each of those expressions, if we added them together, had to add up to 180. And then we could find one or more of those angles from there. Those kinds of application problems might have given us kind of a couple different conditions, but we always had to come up with an expression for each one that only used a single variable, right? There's blue and green marbles in the bag, and there's 3 times as many blue as green. And the total adds up to 100, whatever, so X is the blue plus 3 times X is the green. Maybe I just got that backwards for however I made that, but it was only one variable in that problem. And really, in a sense, it's almost like a substitution problem that we're doing the substitution right away. So those were hardly geometry problems, really, other than we were using a triangle to create an equation about describing the relationship, or we had a rectangle and we created a relationship between the length and width. We got a little more complicated with here's this fencing along a river, and you kind of had to build your own formula, you might say. It's not strictly the perimeter formula, but gee, maybe there's only 1 length and 3 widths because it was along the river. And they still told you how much fencing total. Remember that kind? Still waiting for anybody who wants to say, yeah, let's do one of those or something. Eventually, we did percentage problems in chapter 3. Now, this was a specific kind of application problem in chapter 3. I referred to sort of what I call the 3 basic types, where you could be looking for the starting number or the final percent of number, or maybe you were looking for the percentage. And if we could put the problem sort of into that simple sentence, 5 is what percent of 20, we could translate that sentence into the corresponding math expressions, write an equation, right? And we would look for those values. Then there was sort of the step-up percentage questions where we might say if 20 increased to 25, what was the percent increase? Oh, well, how much did it change by? And then we always compare it to the original, right? Compare it to the original. How much did it change by? And so we figured out how much what the percent increase was. Or similarly, if it went from 30 down to 22, what was the percent decrease? Well, how much did it decrease by? I just made that up. It decreased by 8. So 8 is what percent of the original 30. 8 is what percent of the original 30. So those were kind of two steps. Got to figure out how much it changed by, but then we try to write that basic sentence that compares it to the original value. And then we were looking for percents. We're not going to go looking for the most complicated. We did some weird things where you make 70% of what your coworker makes, and you kind of want middle of the road. Do you understand the basic concepts and maybe some of those couple step kinds of problems where I have to do one thing first and then I can figure out the final value, add or subtract an amount. So percent problems were a specific category of applications that we did in chapter 3. And we also then did, again, in the context of geometry, some Pythagorean theorem problems, right? Remember, if we had a right triangle, there was the Pythagorean theorem that we could use to find a missing side length, right? So chapter 3, chapters 2 and 3, we were solving equations and had a couple specific application types that we were presented there. Chapter 4 was kind of the big step where we jumped into linear equations, two variables, y equals something else, and we wanted to come up with the graphs of those equations. I was a little surprised a couple of you guys got a couple of you maybe figured out a way to get the right answer, but you didn't want to graph the two lines on that last test. You lost points because the problem said solve by graphing and you didn't graph it. You calculated the answer using the other techniques, which was great, but you didn't like graphing the lines or something like that, or maybe you forgot that. Or next chapter. But yes, chapter 4, we for all of our equations, really, one variable or two, we could plug in values to see if it made it true, verify, does this value make it true or not? We tried to graph a line if we had, well, I had that great big, actually, I didn't even bring it with me today, wasn't sure we would get this far. The list of all those possible topics that we covered in chapter 4, being able to read a graph and identify the intercepts, the slope, and eventually being able to write an equation if we had the right kind of information, or picking it off the graph or actually from the information presented to us just numerically, could we write the equation that describes that situation. So that was a big chapter. I mean, there was a lot of stuff in that chapter. And our last one here, we just kind of carried on with that and said, well, here's two lines at the same time. Okay, we have some techniques for solving. So really, I like I say, I've got my sheets here, my review sheets from the chapters. If you'd like me to go through something, we could do that. If you feel like you're pretty comfortable and you just want to continue reviewing on your own, I'm okay with that too, make my life easy. But put me to work here. What would you like to do? Some of. Anybody got a suggestion? If you feel brave, you want to say, can we do some of this? Do you want to if you want me to let you review on your own, that is, try those reviews, do a few problems, and kind of like we did last chapter, send me questions if you're getting stuck, or we could show up tomorrow and you could bring them. I'm flexible that way too. If you want to just get started on your own, do some reviewing, and then find out where you're having questions. That could be our focus tomorrow. I would actually kind of think that would make sense. We should try some practice today, and if you're getting stuck, send me questions, or we should go over it tomorrow. Anyway.
Can we do some percentages?
Pardon?
Can we do some percentage equations?
There we go. There's a good one, right? Thank you. Yeah. Hang on. Excuse me. Yeah. Yeah. finding some here where the numbers might work out nicely, right? Well, let's see. All right. Now I'm making up some problems here, so I tend to kind of pick numbers that I think in my head might work out nicely. It's really process here. So the numbers may seem like, oh, those are easy numbers. Maybe I could even do that in my head, but what we should be trying to practice, I think, is the process here. So here's one of those, what I call the three basic types. And we're looking for the specific number that is 35%, some percentage of. A couple things, well, things we wanted to remember about this translation, right? Well, what are you looking for? That's where you have to kind of define a variable or say, okay, this is going to be my unknown, right? What number? Is or was, depending on the tense of the problem, there's your equal sign. So this number is 35%. Recall, how do we always have to write percents when we're putting them into the equation? We have to convert it to the corresponding decimal equivalent. How many hundredths, right? 35 hundredths, or move that decimal point over 2 places. So there would be the translation from the statement into the equation for this first type. It's kind of the one that's nice because variables already alone, and 35%, like I said, I made this one up in my head. I'm pretty sure if you type that into your calculator right now, you get 70, excuse me, you get 70 is 35% of 200. How did I do that? 35% of 100 would be 35, and I doubled it for 200. Okay, so no great mystery there, right? Here's another type, right? 16 is 15% of what? All right. In fact, just so it kind of works out nicely, I'm going to change this number, okay? If you want, I'm going to make this something that I think will work out to be a number we don't have to worry about rounding. And I'm going to go find my calculator here. There it is. I'm not sure if that even made a difference, but I just wanted to sort of thinking ahead. So again, translating, there's our equal sign. 18 is 15%. Again, we need to do the decimal equivalent of his multiplication, right? But that's what we're looking for. 18 is 15% of what was that starting number that we took 15% of, right? Solving for x just happens to be a decimal value. This is kind of like one that looks like 25 equals 5x, right? We divide by the 5 to figure out what x is. Well, here we're going to divide by that decimal value. It just happens to be a decimal that we're dividing by to get the x alone. And if we weren't using our calculator, that'd be kind of, we'd probably have to do some messier stuff. But let's see. 18 divided by 4.5, and I've got 120. So, yes, I got a nice round number, you might say, right? I want to change. I think if I'd left it with 16, I might have ended up with repeating decimal. That's why I changed it. Okay, and so there's 2 of the types, right? The third type, basic type. Let's say oh, I don't know. I'm going to get some weird decimal or something here probably. 32 is what percent of 98? Oh, we're looking for the percentage value. So what percent, there's our variable, and when I'm just looking for the percent, I always put the P. So I can do the translation here, right? 32 is what percent of 98? So we're looking for this percent value this time. Now, you know, some people, they get this really well and they kind of can step back and say, I'm really just comparing 32 to 98, right? There's 32 98. I'm really just creating that fraction, and then I'm going to turn that fraction into a decimal and the decimal into a percent by moving the decimal point. So my percent is just a comparison, right? Well, let's look at here. To solve for this P, I'm going to divide both sides by the 98. And I'm going to get to that same thing that I kind of said some of you might just come to off the top of your head and figure it out. But now I'm going to do that division. I'm going to put it in my calculator. And let's see, so 32 divided by 98. Yeah, I got a long decimal, right? So I have P equals 0.3265 and some other stuff. Now, that's the decimal equivalent. All right, I want to turn that into a percent. So when we had a percent in a problem, remember we had to turn it into the decimal, you know, by moving that decimal point. Here we're going to turn it into percent by moving the decimal point the other way, right? So here it'd be 32.653 whatever percent, and hopefully a problem like this would tell you to what decimal place to round your percent. Round it to the nearest tenth of a percent. Let's say that, right? Nearest tenth of a percent. So we want to round our final percent value to the tenths place, right? One decimal. Don't try to round this one. That was the decimal. Don't round the decimal to tenths place. We got to change it to the percent first and round the percent to the tenths place. Okay, just emphasizing that. So my tenths place, it's that first decimal place, means I'm going to stop after one decimal, but I always have to look at the next one. That's the test digit, decides whether it's going up or down. So percent here, I was following that rule, I'd say 32.7, right? The 5 goes up, 32.7%. 32 is, it's like, wait a minute, that's awfully close. Well, that's because 98 was so close to 100, right? 32 over 100 would be 32%. But so 32.7% of 98. All right, well, so that was 3 examples of one of the each basic types, one each of the basic types. Let's see. How about this? If 20 increases to 27, what's the percent increase? And the way I usually present this is as a 2-step problem. First, what was the amount of increase? All right, find the amount of increase, and then we're going to compare to the original. So the amount of increase, well, that's just this difference, right? 27 minus 20 means we increased by 7. 7 more than we started with. Simple numbers, you could do that in your head, but talking through a process here. But now we're going to compare the 7 to that original value. So always compare to the original. And I'll write my sentence here. 7 is what percent of 20? or 7 over 20 is what we're going to come up with as a fraction, you might say, that we're going to convert to a decimal. So 7 is what percent of 20? There's my translation there. Dividing by the 20 on both sides, 7 over 20 is going to give us a decimal equivalent. If I do that in my calculator, I'm going to, right, here's a little shortcut. I can turn that into 100 pretty easily. I get multiplying 5 over 5. That's going to get me 35, or 0.35 is what your calculator is going to tell you. There's the decimal. Okay, there's the decimal equivalent of that fraction. And move it over, we'll call that 35%. Is that okay? You follow all that? I'm kind of going off a little side discussion when I say, you know, when we're looking for the percent, we're building this fraction, this comparison ratio, right? I actually saw some of you work out a couple of those problems like that. Didn't have to really rely on the translation. But for you, it means you really kind of understand the relationship. Excuse me. Let's see, let's try another one of those if that's okay, all right? Go the other direction. The same kind of thing though. What's the percent decrease? It's the same kind of problem, only we went down instead of up. If 40 is reduced to 25, what was the percent decrease? Well, again, we went down to that one, so by what amount? You know, 40 minus 25, what, 15? Right? So then we compare again to original. This amount of difference, 15, is what percent of that original amount, 40? 15 is what percent of 40? Dividing both sides by 40 to get that p alone? No. I'm going to get some decimal here. We'll have to round off, I think. Excuse me. Little frog in there. Oh, it's just not too bad. 0.375. It does stop. It doesn't repeat. It's not that kind of decimal. What would my percent exactly be? If it doesn't tell you to round, move it over 2 places, 37.5, 37.5%. 37.5%. Should I make up one more? I have one more kind of type in mind. I'm going to see if I can make up something reasonable here. Remember this kind, after a 30% reduction, a shirt, let's say, sold for $40. What was the original price? This is another one of those, like, there's kind of like 2 steps here. Instead of looking for the percentage, we're looking for one of the other numbers in the problem, but we still kind of have to figure out an amount of difference in a sense. Here's where I would usually say, that's supposed to look like percent up there. Well, 40 is after the reduction. So here's where I usually say, what percent did you actually pay? All right. What percentage did you pay? And if we can figure out that percentage to use, then we can write one of our simple sentences. Well, if we reduced it 30%, you're always subtracting from 100, right? 100 minus 30 means I paid 70. So the 40 is 70% of what? So again, kind of that two-step, figure out, you're not actually using that number that was presented in the problem directly. You have to use it to come up with this difference. Now we can say, we know this number was 70%. So write my equation, 40 is 70%, I'm gonna write it as 0.70 of something. Hopefully that's not too challenging now. Divide by the 70. And this one's gonna give you a messy number here. Yeah, the original price was 57, and since we're talking money, I'll round to 2 decimal places. I've got 1428. You know, I'm going to say it was $57.14. Can't see my decimal point, but that's how much that shirt was originally. It's not too unusual for nice, really nice shirts. You know, like buying nice dresses or whatever, what nice clothing, whatever you buy. But then, yeah, look for the sale. So that was the original price, and 30% off, it's down to 40. Yeah. I say that, oh, here I have my own story, right? I'm kind of a tall guy, not as thin as I used to be, but I buy tall sizes when I buy shirts. Tall, I want, you know, long sleeves. I have to buy tall sizes. I buy a lot of LL Bean because they offer tall sizes. They're a little more spendy, unfortunately, but nice clothes. All right, so that was, again, sort of a two-step percentage type problem. That's as much as you're going to see out of a percentage type problem. Okay, it's as complicated as anything would get. Anybody else? I thought I heard maybe somebody. What I was otherwise imagining was that we might get this far through chapter 2, 3 today, and then we would really focus on sort of that overall chapter 4 review again tomorrow. Let's go through all those different things, concepts that we want to be comfortable with as far as graphing lines and pulling out the right information from a line, or translating an application problem into the appropriate equation or graph. Reading a graph and figuring out the slope. I'm sort of remembering unfortunate errors people made by looking at the graph of an application and not realizing the units were different than just 1, 2, 3, 4. So counting squares just fine, but that square was 50 points or whatever it was. Just the things like that. So spending a fair amount of time on chapter 4 again, and finishing up with a little bit of chapter 5 as much as if we have time for that, although we just got through that again. Hopefully that's still pretty fresh for you. How's that feel for today? You okay? Feel like, all right, Monday morning getting going. Got to put me to work here as review. I do encourage you to maybe even just pull up chapter 1 review and look through that list of problems, and it's like, I could do that, oh, I better practice this one again. The chapter 2, 3 problems. We're not going to throw the hardest things at you, but you know, you've got to sure get a sense of, oh, we did some of this, I can simplify that. We did some percentages. I could do a perimeter problem, or I could do a triangle problem, you know, the width is twice the length kind of thing, or vice versa. Okay, I would encourage you to look through those reviews, figure out where we should practice some more. if you want some extra practice. Okay, I feel like I kind of talked away a lot, but I'm glad we did something here with perimeter today. I mean, with the percentages today. Okay, if you're okay with that, I'll leave it to you to get started on some review. As always, send me questions and I'll get back to you. And we'll do this again tomorrow, all right? Good enough? All right. Well, good to see you, sort of, again, anyway. I don't know, I'm sure it's just part of it is the online nature of our course. We started with a dozen people who registered, and I really have really only 4 or 5 of you who are sticking it out to the end of the class. A lot of folks just kind of stopped, and it's too bad. I'm glad to see you are all still here, those of you who are here. So good. All right, have a good rest of your Monday, and I'll see you tomorrow, okay? We'll keep doing this.
Thank you.
All right, you're welcome.
Steve, I have some questions.
Okay, is that Christina?
Yes, this is me. Hello.
Hang on, let's see. Looking at, yeah, it looks like the others have, so we're alone is what I'm getting at. Okay, let me, pardon me, before you, I'm going to